we've heard about sustainability in the SUS part of SusCoRD expressed in dollars and pounds, and maybe even yen and euros. But how should it have been expressed? Question.
I think efficiency, things like this. I think in terms of impact that we have on the planet and the environment, from our point of view, trying to make sure that we can do things as effectively without having the minimum impact. Stuart, your view?
I have lots of views, but one thing that's often not said is the sustainability of our activities. The sustainability of the Corrosion Protection Centre at Manchester. The sustainability of the business to generate new paints. These are very important, because without these things, we don't have novel activities. We don't have novel businesses. We don't have novel ideas. We need the sustainability of new ideas in whatever genera, whatever aspect to bring in to life. Otherwise, we wouldn't get mobile phones. I remember a life without mobile phones. I remember a life with only one TV channel, which only happened 3 hours a day when as long as it didn't rain, because I was in the middle of Scotland.
So, building on what Stuart's just saying, one of the things I've just got through on the emails, which I wasn't reading, obviously, was basically the RSC is doing a survey on what needs to go into education for sustainability. And it's all about teaching people about low energy, about carbon cycle, which is great. And then they're saying, rate 3 of these. The fundamental things are there is no such thing as from, and there is no such thing as away. We've got one planet, and basically, we've got to make sure that those things are, within the planet doable. Energy is often put as being the issue. Carbon is generated by energy, but actually energy is not the problem, because we can generate lots of it, but it's just the ways in which we do it. And I think those, from an educational point of view, that, Stuart with his MSc for 60 years in corrosion has been very much teaching people that, if your asset falls down, it's gone.
Well, we hear this thing about X% of GDP per annum, and it means absolutely nothing to anyone. However, imagine a straight line depreciation, which is economically illiterate, I know, but if you imagine straight line depreciation, 2% per annum, 50 years, nothing has any economic value at all. Only due to corrosion, not even mechanical damage, just corrosion. So all around you will have vanished in 50 years. It will have no value unless we put corrosion protection into it. That creates a sustainable environment for us to live in. Now, how can we make that sustainable environment better is the question that we have to do. Can we make paint sustainable? People have talked about sustainable paints by not by using hydrocarbons, by using different precursors.
Let's hear a voice from the floor. How do you think we should express sustainability for coatings? Anyone with a different view to these 3 old white men?
I'm afraid it's another middle-class old white man. But when you stop mining stuff, when you stop mining, right?
Stop mining.
Mining, because mining is a process of taking stuff out of the earth, using it, and forgetting about it. Okay. So the process you need to do. So what happens to your paint? It's on a ship. Where does it go?
Funnily enough.
Well, yeah, but that I see the point of So I've got a pot of paint at home. Currently, there's no way of doing anything with that. The council don't accept it. I've got to use it up. They want me to paint it and stuff. But in the field, I'm putting it on the house or the shipyard. It gets applied. Where does it go after that?
In terms of your local paint, there should be a thing called free paint, and I think in Sheffield there is. It's not around in the country. So we're trying to take that paint back in you can't use. Paint is fundamentally a dispersive thing. We are spreading it absolutely around the world very thinly. So I think in the long term it needs to be circular, but not necessarily circular where it's captured. It needs to end up back in the biological thing. At the present time, we've got to make that as efficient as possible. So that paint, on the ship, the value of that ship in terms of energy, which is our current, huge problem, is the CO2 given out by the energy from making the ship and things. But where does it go? Yeah, it's taken off in the shipyard at the end. The ship is blasted. it's repainted. That scrap is dealt with as waste. And, similarly for paint on your walls, it ends up in landfill at the current time. Is that sort of what you were...
What I'm looking at is it's still got value in that. You've still got zinc, or you've still got oxides, or you've still got whatever you've got is still in that paint.
Yeah, and there is two values in there, you're right. I mean, one value is the economic one, which tends to judge things personally. But in the long term, if paint is still going to be dispersed, if it's going to end up spread, the value in that resource-wise that you were talking about, mineral, has to be totally replaceable. So if it ends up as calcium carbonate or something, that is not a material that we have a shortage of.
How would we make this decision? Anybody? I'm not so old. Yeah. It comes down to life cycle, doesn't it, Tony? And if we're starting to look at recycling stuff, we have to look at the embedded energy that we put into these materials. And I think that's where a lot of the manufacturing comes into, like, can we use lower energy manufacturing or smart ways of doing things that we've traditionally done in sort of high energy intensive ways. And it may be that it isn't, Tony, it's a very appealing thing to be able to recycle things, but if the energy benefit is actually too high, then is that something that we would go down? I mean, in the end of the day, we're trying to get to a point where we reduce our carbon dioxide emissions, and ways in which we can use low carbon free energy, then that's where the life cycle analysis comes on. And I know that sometimes it's a bit unclear as to what is a good life cycle analysis, but I think it's basically not putting carbon dioxide into the atmosphere that's going to alter our environment for everyone on the planet. Anything else? Anything else?
Yeah, I was going to make some comments, but actually I've already touched it. Yeah, recently EPSRC has sponsored a project called Circular Metal, where we ever have a circular coating.
Richard, I think Richard's a comment. One comment I had is 2,000 years ago, paints were fully sustainable because they came from sustainable materials. Things like linseed oil, etc. So the reason we now have modern paints is because they work better. Can we make old-fashioned paints work as good as modern paints?
I think, so what's the unit we should use? I think the unit we should use is oil or carbon dioxide. I do think the only thing that, well, it's not quite the only thing that matters, but the only thing that matters at the moment is greenhouse gases. So it's oil, carbon dioxide, methane, the other ones. I think we have to ask ourselves, what's the embedded oil in the asset you're protecting? I think it would be, I think it would be wrong to use to have a product that was more sustainable but that was less effective if the product it was protecting outweighed vastly the energy cost of the paint. So I'd like to say, how much oil is there in a ton of steel that you're protecting? And Tony and I used to know these numbers, but I've now forgotten.
It's about 2.5 tons of oil embedded in a ton of steel.
No, I think it was only that way around for aluminium. So for planes, I think it's less, but it's the same order of magnitude. So I think you should think about how many tons of steel are there in a wind turbine pillar. How much do you want to trade off? Every year that you prolong the life of a wind turbine pillar is effectively a huge amount of carbon dioxide you've saved. So I think that's the trade you should make. So so my answer is I don't think you should worry about sustainable paints. You should worry about sustainable systems. And if the paint is the tail, it shouldn't wag the dog of the entire system. That's my popular view.
Well, yeah, I was going to say asset extension, lifetime asset extension is the thing. I'm reminded of the Forth Bridge. That's a road bridge, not the rail one, where they designed it to last 50 years, the suspension cables. And you can put new suspension cables on a suspension bridge. You just have to close it down while you're doing it. It was cheaper in a life cycle basis to build a new bridge than to close that bridge down, which is somehow crazy, but from the cost of putting the new cable up was a few $100 million, but the cost of traffic delays was over $1 billion. So in terms of life cycle costing, we have to take very strange things into account in order to get the true economic costs to the economy. So it's very, very short-sighted to focus on one tiny wee component of the life cycle rather than focusing on the big picture.
So right, go on, please.
Just an assumption. Can you use conducting polymer in your painting and get electricity from that paint and use electricity in your house and these things?
So that question is about making paints more smart, and this is being done. There are paints being designed to make buildings essentially energy capture devices by using smart paints.
Not so much through photoelectric, but through making sure you're absorbing the energy coming from the sun. I mean, you're absolutely right. I mean, in terms of it's the assets where Protect has a big effect. As a company, just put an AkzoNobel point of view, we have a challenge. We've set ourselves challenging goals to reduce our own carbon footprint because that's what we can control directly. But I think our impact, and the same with other coating companies, is far bigger around the assets we protect. I mean, in terms of the Forth Road Bridge, we have to, I think that's one of the things we struggle with. And I'd also say, Patrick's question about the sustainability, it could be a delayer to actually, if you say the paint's got to be sustainable, it could delay putting up wind turbines because you can't make the paint sustainable. I think equally, economic arguments about road transport could once again delay because actually they keep the systems that are going currently. And this is why it becomes a huge systems problem.
So one thing we've got to is we have to talk about the system, right? Yeah. And we have to deal with trade-offs. So one trade-off would be the outside of my house has just been painted. The wood, the forestry approved wood is protected by an organic coating, a paint that had volatile organics in it. It was a solvent-based paint. The last bit of solvent-based paint the painter could get his hands on. It was actually an AkzoNobel product. And it made me think, if I do the LCA for painting it once every 10 years with a VOC paint versus every other year with a waterborne paint, which is doing least damage to the environment? Right? And the problem is that we have a policy brought in by lawmakers that was based on a single issue, which is why it's really important to think about the system. So, no, come on.
So just to add to that, when a company's drives for sustainability conflict with their business interests, how can you have a sustainable world when you have a business model which is based on continuous growth?
From a supplier, with you all the way, or with even the materials which are cheaper, you're going to be taking those materials from parts of the world where you don't have to pay so much for them. Are we going to make products more expensive in our quest for sustainability?
I think from the corrosion protections perspective, sustainability is a very complicated thing. We talked about systems, etc. People have talked about using natural ingredients for corrosion protection and how wonderful they are. Many natural ingredients are downright poisonous, and you don't want anywhere near them. But we're asked now to shove things like digitalis into materials because it's a very good acidic corrosion inhibitor. No, it's just completely bonkers. So some of the sustainability drivers lead us down pathways which are just plain wrong. And that's just why I keep saying, going back to how to avoid greenwash. Thank you, Tony. That's a good way of putting it.
It was pre-prepared.
In green.
All I had to do was flip the chart.
No. Sorry. It's a great question. I mean, in terms of companies, I think you've also got to be careful. There aren't systems out there, the way in which, it's bigger than companies. It's the whole system around it. And there can certainly be situations where legislation, for one thing, actually drives unsustainable practices. I mean, standards have been put in place on paints for very good reasons, for safety reasons, but technology's moved on, and there can't be more sustainable paints made until those standards are changed. So, you're right, and I think where, ingredients, but in the end, if those standards are taken out and other, systems are changed, then it's often in the business's long-term process, and then it's the right costing for carbon. To do a blast for AkzoNobel, we have a carbon tracking system for ships because we put anti-fouling coatings on ships. That makes the ship more efficient. They can trade their carbon. That encourages them to put our paint on their ships. It's a little thing, but it's little things like that that sort of help. But no, it's a good question. I think you've got to be careful, and we certainly do not want to greenwash, and hence we compare our products often to our own rather than other people's, because we don't truly know about their carbon cycles, but we can tell you about the LCA for our own paints, and that's what we try and do.
And I guess to come back to this issue, the key thing for businesses, whether or not you think capitalism's broken fundamentally, and you might gather that.
That wasn't the conversation.
Yeah, no, and well, I'm not sure it is, but anyway, but decoupling economic growth from resource growth is the conundrum that science faces, that technology faces, that innovation faces, and I think we need to be cognizant of that problem in our research, which brings me to my last question for you, which is, how do we change the way we work, right, in the detail of how we work in the lab in order to be more efficient? I don't want to say efficient. I actually want to say, how do we reduce resource consumption and still do our science? Are there things we can change in the way we work, for example, by not using single-use pipette tips, might be one example. Are there working practices that are just normal to us that we could actually improve? Just to finish on something that's intensely practical. Any offers from the room? More modelling, less experiments.
Yeah, more modelling. Work out on a computer, then you don't need to do the experiment.
But on the flip side to that, and as a modeller, I feel I can say this, is you're shifting your carbon production to massive computers. So you have to pick your models carefully and do not just run loads, do smart models.
So never was the second law of thermodynamics and information being energy brought home to me than when I went to Oak Ridge National Labs, where the cooling for the supercomputer building was bigger than the supercomputer building. Richard. Oh, sorry, Stephanie. Did I walk past you? I apologise profusely.
It's just on the sort of modelling versus experiments. Just it's a really nice thought. But when it comes to things like safety standards, and I'm sure AkzoNobel appreciates this, you can do all the modelling you want, but nobody's going to approve the safety standards unless you show them the actual thing in person. So you're going to have to still do it.
You ultimately have to validate the model.
So in Sheffield, I was involved in thinking about how can we kind of reduce the carbon footprint of the research, and it kind of started out in about 2010. Basically, there was a kind of single meter at Western Bank that just kind of ran up and said, "Oh yeah, 20 million this year." One of the things we did was then kind of break down where in the institution the electricity was being used, and number 2 place was his growth chambers, where he was doing all kinds of marvellous experiments about making plants grow better. But number one, just the computer lab, that people do not understand how energy intensive computers are. And well, I mean, we can feel how hot our computers run, but mostly, we've offloaded it onto the cloud. And the energy consumption of the cloud has been growing exponentially. I mean, the good news is, I mean, you talk about the second law. It's always good to say, where is there a, what's the hard limit? I mean, there is a hard limit on energy in computing, which is the Landau limit, as you probably know. And it's kind of interesting that actually we're about we're orders of magnitude away from that limit. Okay, so maybe I'm just saying we just need to encourage our colleagues to actually do some proper work on low energy computing, because there's a kind of huge amount of gains to be got there.
Great, thank you, Richard. Good point. Who knows? Who knows? I guess Tony, that's brilliant to end on a practical point. I mean, I'm about to retire from AkzoNobel, so I don't have as much of a conviction as I did. I think it's really good. Look at companies who are actually putting solar on top of their painting plants. AkzoNobel. But, I'm sure other people are as well. It's things like that you can do positive. I think your business about, pipette tips or whatever it is, it all adds up. It won't solve it, but all those things. And then it's what you request. I mean, this meeting will have had a bigger carbon footprint than if we'd done it all virtually, but there would have been a non-zero footprint to that, and it's the value of what you get out of it. So efficiency, but, it's not its efficiency, but its effectiveness. If we've got the extra benefit from being here, then that, fits into your LCA and possibly justifies it. I mean, what does a university, what does a company have as its carbon reduction strategy? AkzoNobel has put in place a very public recent strategy, and we're saying it's better than everybody else. We get judged quite a lot by different financial organisations. You slightly, if we're being judged by Dow Jones, are there the people who should be judging companies, or would you like somebody, different to do it? But, it is our society as well. AkzoNobel is only a company. This is only a university. The EPSRC is very much UK-based. What do we want in the world in the future? Sorry.
And just to close, if that's our only metric, we're stuffed. We have to have other metrics. And it's really important for us to remember that in our research and in the communication about our research. It was really, really nice to see the reason we're doing SusCoRD is because of the economic cost of corrosion. What I'd really like to see in future is the reason we're doing SusCoRD is because of the total environmental cost of SusCoRD, and how do we work that out? Any more from the floor? Well, thank you very much for joining in that 20 minutes of discussion. There was plenty from the floor. The air conditioning, which is evaporative cooling, has clearly run out, and the room's getting warm. So thanks all.
Thanks for coming.